On my screen, I have the drawing for the Crankcase. It's part of a Radial engine project. It's a miniature or model engine. And we're going to model up this part inside of Mastercam. And if you look at the project page on Canvas, there are some step-by-step instructions on how to approach modeling up this part. These instructions aren't set in stone. If you deviate from these instructions or deviate from the steps, as long as the model is complete and correct, these are just our suggestion or recommended steps that you would follow to complete this model. And I'm going to follow along with the instructions given here. So on the project page, you'll see an image of the drawing. And then there's some instructions. Use the drawing above, generate a three-dimensional model using the Mastercam software. Step 1, use the polygon tool to create the part profile on the right C-plane. So what does that mean? So look at the drawing, and then inside of Mastercam, well, let's start a new session of Mastercam. And when I'm modeling something up inside of Mastercam, I like to maximize my graphics area. So I'll close out of any managers that I might have open. And I'll look at it from an isometric view. Now, if I go back to the drawing, I'm going to model up the part so that my default isometric view matches this isometric view right here. It's not necessary to do it that way. I like to do it that way because when I'm troubleshooting the part or as I'm building the part, it's nice to quickly look at it from a default isometric view and then compare what I have on my screen to this image on the drawing. I'm less likely to miss something, or if something's out of place, it jumps out at me, it's a little bit more obvious. So the first instruction, use the polygon tool to create the part profile on the right C-plane. The part profile, I'm going to identify that or call that this hexagon that I'm tracing with my cursor. It's a hexagon that measures 4.25 across the flats. So what I'll do is I'll start by drawing in this hexagon. I'll use the polygon tool to do it. I'll create it so that it measures 4.25 across the flats. And then I'm going to draw it on the right side construction plane so that when I extrude it, my default isometric view matches this isometric view. So this is what I'm talking about. I'll go into Mastercam. Now, if I draw a circle or if I draw the polygon on the top plane, the default plane, if I go to wireframe, circle center point, and I just draw on a circle, you see how this circle's planar with the current XY plane? For me to create a model that matches, create a model so that my isometric view matches this isometric view, I got to change my construction plane to the right. So I'll leave the circle here temporarily. You don't need to have this here. This is just for a reference. I'm going to change my C-plane to the right. So if you come down here where it says C-plane, select it, and then set it to right. And when I did that, you'll notice that the XY plane is now, this is my positive X, this is my positive Y. Anytime we create two-dimension or 2D geometry, it's planar with the current XY plane. So what I'll do now, from the wireframe tab, under rectangle, expand rectangle, you'll find a polygon. Select polygon. For the number of sides, set it to 6. For the radius, set the radius to half of the distance from flat to flat. So 4.25 divided by 2. The radius is 2.125. The radius is set to flat. We could put corner fillets on there. We'll talk about that in a moment. The rotation angle, we'll leave it at the default. And for settings, I'm not going to check either correct or neither create surface or create center point. when I move my cursor into the graphics area, you can see a preview of that rectangle or of that polygon or of that hexagon on my cursor. I'll let my cursor lock on to the origin, and it didn't hold its size value, so I'll approximate the size, and then I'll come over to the radius value, and once again I'll type in 4.25 divided by 2. I'm tumbling my view. We have the ability to create the fillets on these corners. So if I go back to the drawing, the fillet or the radius on the sharp corners is 0.25. So set the corner fillet to 0.25, and then you'll see those sharp edges now have a fillet on, or now have a radius on them, or they have a fillet on them. So 6 sides, radius value is 2.125. Corner fillet is 0.25. I've got the radius to the flat, so the distance from the center to the midpoint is 2.125. And I've got my rotation angle set to 0. From here, I'll select OK. I'll look at it from an isometric view. I don't need this circle, so I'll select the circle and I'll delete it. How's everyone doing?
Good. It's weird. It looks like I have like one origin over the other.
Oh, can I see your screen?
Yeah.
I think you might have your construction plane and your tool plane visible. Oh, I see what you're saying. Yes, that's the case. So go up to View, and under Show Nomens, uncheck Tool Plane. So expand Show Nomens. The arrow underneath, no, turn it back on. And then turn the tool plane off. And turn WCS off also.
Okay.
So we're just looking at the construction plane. So that looks good.
All right, cool. Thank you.
You're welcome. All right, let's go back to my screen. How's everyone else doing? Is there anything I can help you guys out with? Any issues?
Oh, good to go.
No, good.
Good? All right, nice. So if we're good up to this point, go back to the project page and you go to step 2. It says, use the extrude tool to create the 2.25 thick base feature. So if I look at the blueprint and I zoom into this view, you can see that the overall thickness of the part is 2.25. And I'm going to extrude it in a direction that keeps the origin on this front face, and it keeps the solid support geometry on this front face. So I'll go back to Mastercam. But before we create the base feature, let's go to the Home tab. Let's set the solid color to something that's currently not being used. I'll set it to this blue color right here. So I don't want my wireframe color or my solid support geometry color and my solid model color to be the same. So I'm changing that up a little bit. So from here, I'll go to the Solids tab. I'm going to use the Extrude tool. The wireframe chaining dialog box pops up. Mode is set to C-plane. Selection method is chain. I'll select one of the entities that represents this profile. You can see that the entire chain becomes selected. I don't have any breaks in the chain. I have one green arrow. I'll select OK. I want the extrusion to go in the other direction, so I'll select reverse or reverse all. And then I'll set the distance to 2.25. And you can see that the coordinate system or the origin is on this front face, and the solid support geometry is also on this front face. From here, I'll select OK. I'll look at it from an isometric view, and let's save this as Crankcase. So in the class folder, I'll create a new folder and I'll call it Crankcase. And I could also even call it Radial Engine. And then inside that folder, I'll just give the Mastercam file the same name. How's everyone doing?
Good.
Doing good? All right, cool. So from here, if you go to the drawing, you can, we don't have a lot going on yet, but if you did a quick comparison between this isometric view and the one that's on our screen, you can see we got a lot to do, but if something's missing, it has a tendency to jump out at you. It's obvious when something's not right, or it's a little bit more noticeable, I should say. So from here, I'll go back to the project page. And that's the drawing. Here's the project page. Step 3. Use the extrude tool to cut a 3.5 diameter hole 1.81 deep in the part. So if I go to the drawing and I zoom into this view, you can see that there's a hole in the part. And if you look at the isometric, I'm talking about this hole right here. It measures 3.5 in diameter. And then according to this dimension, it's cut 1.81 inches into the part from this top face or from this open face right here. So what we'll do, we'll go back in the Mastercam. We're going to draw a circle centered at the origin that measures 3.5 inches in diameter. Go to wireframe, circle center point. For the diameter value, 3.5. Let your cursor lock on to the origin. Double check the value, make sure that nothing has changed, and then select OK. If you're good up to this point, use this circle to do an extruded cut for a depth of 1.81. I'll go to the solids tab. I'll go to extrude. This time I'll select the circle that we just created. I'll select OK. For the operation type, set it to cut body. If you're not seeing a preview of the cut, you might have to flip the direction. You'll select reverse all. And then set the distance to 1.81. If everything looks good, select OK. And then I'll look at it from an isometric view and I'll save my work. If I look at the isometric view that's provided in the drawing, you can see that things are starting to take shape. How's everyone doing?
Good.
Good. Yeah.
Nice. All right. Let's go back to the project page. Let's see what we're instructed to do. Step 4. Use the bolt circle tool to create 6 points equally spaced on the open face of the part as shown. Okay. So this is the open face right here. I'm going to call this face right here the open face. And it's telling us to create 6 points. Let's see here. Use the bolt circle tool to create 6 points equally spaced on the open face of the part as shown. Referring to this call out right here, 6 times 0.201, and this is a hole call out for a 1/4 20 fastener. they're telling us that we need to drill 0.201 deep. I'm sorry. It's telling us to use a 0.201 or a number 7 drill and drill to a depth of 0.65. Then we're going to tap with a 1/4 tap and create threads that are 0.5 deep. Now the countersink, this is a SolidWorks standard or SolidWorks call out. They're calling for a countersink that measures 0.265 by 90 degrees on the near side. The order that you see this doesn't quite work. I would actually create the pilot / countersink first, and then I would come in with the drill, and then I would come in with the tap. You're not going to tap, drill, and then countersink. It doesn't work that order. It has to be in a logical order. So I would create my pilot, and then the pilot would also double as the countersink. I would come in with a number 7 drill to this depth, and then I would drill or come in with a tap and create the threads. But for what we're doing right now, we just need to create this pattern. We're going to use points and circles. Could use points or circles, but we're going to do both. The bolt circle diameter is given to us by this dimension, 4 inches. And it doesn't say, but these are equally spaced 6 times. So the angle between them is 360 divided by 6, 60 degrees. We have a tool inside of Mastercam that will help us make these very easily. Go back into Mastercam. Go to wireframe. In the points section, you'll see bolt circle. Select bolt circle. And right away it says select the base point. It doesn't let you enter any information into these fields until you select the base point. Let your cursor lock on to the origin or the center of the hole. Then it shows you a preview of the bolt circle. Let me fit my screen here. That's not working the way I wanted it to. So the default preview has 8 times. The bolt circle itself is a little large. So let's make a few changes here. Set the method to full circle and set the number to 6. For the diameter, you go back to the blueprint. The diameter is 4 inches given to us by this dimension right here. It's pointing to this theoretical circle that connects these 6 holes. So set the diameter 4. Now I can zoom in a little bit more. Start angle, we'll leave it at the default. It's the way we want it to be. Arc diameter, set this to 0.201. I'll model up or I'll draw in a circle that's equal to the diameter of the drill prior to the tap. I'll hit enter. So it's starting to take shape. For the create entities, I've got arcs already selected. If you select reference circle, it's going to create the circle, the theoretical circle that connects the points or connects the circles. And if you wanted to create center points, you could do that also. I'm not going to create the center points. I'm just going to create the arcs that measure 0.201 in diameter and the reference circle. From here, I'll select OK. And it creates our bolt pattern. Now, granted, it's made out of 2D geometry. We can go in and we can create the holes using the solids tools. So how's everyone doing up to this point?
Good.
Good. So in the past, what we would do is we would draw in one circle placed on this reference circle, and then we would do a circular pattern with the whatever number of holes and whatever spacing that we needed. So this bolt circle tool speeds up the whole process. All right, so from here, save your work. We'll go back to the project page. And we're on step 5. It says use the hole tool from the solids tab to create the 1/4-20 holes on the open face of the part as shown. Now, this is, I should have worded this better. When I model up holes or when I modeled up threaded holes inside of Mastercam, I'll model up the countersink and I'll model up the diameter of the drill that we're going to use prior to running the tap. If it asks for a 1/4 thread, I'm not going to put in a 1/4" hole because I've been in situations before where we're working off of the model and someone mistaken the 0.25 diameter holes as a drilled hole as opposed to a 1/4 threaded hole. So when I model up, Mastercam doesn't show true threads well at all. So I'm going to model up the drill that's used prior to tapping. And in this case, it's a number 7 drill, 201. So what I'll do, I'll go back in the Mastercam. And before we do that, go back to the drawing real quick. If you look at the call out's calling for a 0.201 diameter drill to a depth of 0.65. And the way I interpret this 0.65 depth, this is the full diameter. This isn't to the tip of the drill. So we have a full diameter of 0.201 to a depth of 0.65. Go back to Mastercam. Go to the solids tab. Select hole. Now it says use panel to modify the hole settings. Before I select the locations of these holes, go down to hole style, use countersink. For the diameter, set this to 0.201. For the countersink diameter, go back to the drawing, 0.265 by 90. So for the countersink diameter, 0.265. And then for the countersink angle, set this to 90. For the depth, set the depth to 0.65. That's coming from the blueprint. Right there. Now, where it says plane orientation, select C-plane. So under plane orientation, you see this icon right here says C-plane. It changed it to the current C-plane to the right. And now in the positions field, if I select add position and I select this circle, it places a point there. And I'm going to work my way around to the other circles. Be careful not to lock on to the midpoint. And it doesn't seem to let you do that. So if you select the circle, it automatically places a point at the center. And as soon as I hit enter, you'll see a preview of those holes being created in the part. So it's got the countersink and it's got the 0.201 holes to a depth of 0.65. I'll look at it from an isometric view. I'll select OK. And then I'll save my work. How's everyone doing?
Doing good.
Nice. Is anyone having any issues that I could help resolve? There was a lot going on with that step, or with creating those holes. So if you have any issues, please let me know. All right. So if everyone's good, make sure you save your work. And we'll go on to the next step. We'll go back to the project page. So we just did step number 5. Use the hole tool from the solids tab to create the 1/4 holes. Number 6, use the bolt circle tool to create 2 bolt circles, both equally spaced on the back face of the part as shown. So what's going on with that? if you look at the drawing, and we've got multiple views. This is the back view, or the view of the back face that we're seeing right here. And if I zoom into it, there are two bolt hole circle patterns, or two bolt circle patterns. One will once again be a 1/4-20. Now they rounded, this is a rounding issue. This will still be a number, a 0.201 diameter hole. And then using a 1/4-20 with the countersink of 0.265. So similar call out to what we just did. And then we have another bolt circle. This time it's for a 0.188 diameter hole. And these holes are going to be 0.25 deep. So what we can do to speed up the process, we can go to the bolt circle tool inside of or from the wireframe tab and create this bolt circle, and then we'll create this bolt circle. And then we'll go into, I believe we're going to go into the same hole tool and create these holes that are based, or that are located on this bolt circle. So I'll go back to Mastercam. Now, if I look at it from an isometric view, the holes are on the other side of the part. I've been using the right side construction plane to create all of this geometry so far. I'll tumble my view a little bit so that I can see this back face. Now we could use the right side construction plane to place this geometry, but I want to show you guys that you can flip things around. This time I'm going to use the C plane left. So where it says C plane right, left click on it, then change it to C plane left. And then I'll look at it from, let's see here, there's a right view. If I go to, let's see here. Okay. Let's do this. Now I'm going to jump ahead. I'm going to do something different. I'm going to create one of the holes that goes through the part. And in hindsight, it would be easier to create the 0.531 diameter hole that goes all the way through the part. And then we can use that to lock onto when we place these next two bolt circles. So let's change the order of this a little bit. Let's go down here, and where it says step 9, we're going to put step 9 in front of step 6. It says use the hole tool from the solids tab to create a 0.531 diameter hole on the back face as shown. What I'm going to do, I'm going to make that hole centered on this face right here, the bottom of this circular pocket. Because there's already a center point that I can lock onto, I don't necessarily need to draw in the geometry, but let's do that just to be consistent. Let's draw in a circle that measures 0.531 in diameter, centered on this back face. If I go to the wireframe tab, I'll select the circle center point. For the diameter value, I'll type in 0.531. And then I'll let my cursor lock onto the center of this back face, the face that's at the bottom of the pocket. I'll select OK. Now there's a couple different ways we can approach doing this. We could use the extrude tool and make a cut with this circle, or we could use a circle to position a 0.531 diameter hole. Either way would work. If I go to the solids tab and go to extrude, I'll select the circle. I'll select OK. I'll need to flip the direction. And then I'll just set it to through all.
Patrick,
Yes, sir.
when I created that hole that one we just did, it actually put it on the front side of that face as if like that.
Oh, right here.
Yeah, that if like as if that larger hole wasn't there. No, on the other side.
Oh, on this side. Can I see your screen real quick?
Yes.
All right, let's see what you got going on. Okay, interesting. So let's do this. Go back to the circle tool.
Here.
Yep. And set the diameter value to 0.531. So you're good. Now, position your cursor on the inside edge of the pocket, the bottom of the pocket. So go to the bottom. I'm sorry. Go to right, like lock on to.
So I positioned it here on the.
No, you don't want to do that. So go to the bottom edge of the circular pocket.
The bottom edge here?
Yeah, right there. See how it's locking on?
Oh, I see. So click here.
Yep. Looks good.
Okay.
So you're good. We'll go back to my screen.
Click OK.
Yep, you're okay. So click OK. And then make an extruded cut with that goes all the way through the back wall of the part.
Okay, and I can delete the existing or the other
Yes,
circle.
it's not, there's nothing dependent on it. So when you delete it, you shouldn't have any issues.
Okay.
Now, if there was some type of solid feature dependent on it, we would not want to delete it.
Okay. Thank you.
You're welcome.
Patrick,
Yes, sir.
we have to work everything off this side, or is there a way that we could like?
There is, but I'm trying to approach it I'm using the easiest methods possible that I'm seeing right now.
Okay, and I'm having a trouble with my origin again. It's showing the right one as well as the left.
Okay, can I see your screen?
Yeah.
Interesting. That would be so go back to view and go to expand and show nomens. And deselect selected planes. And then deselect use origin color. Okay. Yeah, and then select T-plane and then turn off the C-plane. Let's see what it does. Okay, so make C-plane, turn off T-plane, and then check use origin colors. There you go. So that's what mine looks like right now.
So how did?
I don't know. I don't know. So, I'm comparing your settings to mine, and right now your settings match mine. And how that came up, there sometimes we're presented with these mysteries, and sometimes they just disappear. They fix themselves. I don't know why I was doing that.
Yeah, it's weird because it's pretty much like.
No, it looks good now.
All right, thank you.
We had it fixed once. Oh, do me a favor. Let's try this real quick.
Okay.
It might be an issue. Go to your plane manager. So go to view planes. And if anyone else is following along, you see the two green arrows that are kind of forming a circle, the follow rules up in the top toolbar of the plane manager. Expand that. Uncheck that last one. I think that's the culprit right there. So
weird.
Yep, there you go.
The same thing was happening on mine until I selected the plane manager, and then now it's back and it seems to have fixed itself too. The same thing was happening.
Okay. So do another thing that you can do. Make the right plane. Select the right plane, and then hit the equal sign, or set it to left plane and hit the equal sign.
Okay.
And so that seems to be working, and the reason being is that the two are sticking together. But why they keep breaking apart from each other is because I have the same settings you do, and I'm not having that issue.
Yeah. So That's unchecked. And okay.
It's not going to prevent us from what we need to do, but I can see where it's kind of a nuisance.
Yeah, I'm not sure. So
But it looks good now. If it happens again, just let me know.
okay, thank you.
All right, cool. All right, so go back to my screen. And I'm looking at my part. Now I have a center point that I can lock onto to position the next two bolt circles that we need to create. So what I'll do is I'll tumble my view so that I can see this face right here. And I've got my C-plane set to left. If I go back to the drawing, let's start by creating the bolt circle that measures 3 inches in diameter. And we're going to have some 0.201 diameter holes 6 times equally spaced on that bolt circle. So I'll go into Mastercam. I'll go to wireframe.
He's going on this one.
I'll select bolt circle. For the method, full circle, number of holes 6. For the base point, it's not going to let me change any of these settings until I identify the base point. Lock on to the center of this hole. And this is why the order that we created, we're creating these things made a difference. Making the bolt circle before I had this hole available to me would have been more difficult. So here I can lock on to the center of this hole. I'm getting a preview of the bolt circle with the previous settings. Set the diameter of the theoretical circle to 3. Let's check that value if I go back to the drawing. Yeah, so 3 inches, we're good. And the diameter of the circles, 0.201. I'm creating the arc, the 0.201 arcs, and the reference circle. Everything else looks good. I'll select OK. And if I thought about it ahead of time, I would select OK and create new operation because that'll let me go back into the tool. But if I select OK, then I got to go back to bolt circle. And this time, if I look at the drawing, once again, we're going to have 6 holes, but you'll notice that the orientation is a little different. So this time, one of the holes is going to be at the 12 o'clock position, whereas the previous orientation, the holes were at the 9 o'clock or the 3 o'clock and the 9 o'clock. Now I have them at the 12 o'clock and the 6 o'clock. Still 6 times equally spaced. The angle between them is 60 degrees. We just have to rotate it a little bit. And the rotation from 0 should be 60 if I'm sure it should be 30 if I'm not mistaken. So I'll go back to Mastercam. I forgot to check the bolt circle diameter. So the diameter this time is 1.75. So diameter, actually it says, please select the base point again. So lock on to the center. Set the diameter to 1.75. Set the starting angle to 30. Yeah, angle 0 would be the 3 o'clock or the positive x-axis. I rotated it 30 degrees. Now you can see that I've got an instance of these holes. One's at the 12 o'clock, one's at the 6 o'clock, so that's correct. Set the diameter of the arc to 0.188, and that matches the call out on the blueprint right here. From here, I'll select OK. This would be a good time to save my work, so I'll select File, Save. So from here, I'll go back to the instructions. So it says use the bolt circle tool to create 2 bolt circles. We did that. Step 7, use the hole tool from the solid tab to create the 1/4 holes on the back face as shown. Go back to the drawing. the holes on the outer bolt circle, these are the 1/4-20s. So what I'll do is I'm going to draw in a drilled hole that measures 0.201. I'll update this drawing. This is off. Should be up. Should be 3 decimal places. And they're going to go through the wall. And then I have a countersink 0.265 by 90 degrees. So I'll go into Mastercam. I'll go to the solids tab. I'm going to use the hole tool. It's holding on the settings from the previous, from the last time that we used this tool. So it's using a countersink type tool or type hole. The diameter value is still 201. The countersink diameter is 0.265. The countersink angle is 90. And for the distance, set it to through all. Now we need to change the plane orientation. I want the plane orientation is going to tell it which side of the part, which side of the face to place the countersink. So let's set the plane orientation to C plane. I've got it set to left. Now, if I look over the different select face, select plane, if I go to select plane, it'll bring up this dialog box and then we can select the plane from this menu. But I've got the plane orientation set to left. In the positions tab, I'll select add position, or in the position field or underneath the position field, I'll select add position. And then I'm going to select the 6 circles that represent the drilled and tapped holes. As I select the circles, you'll see a point being placed at the center of the circle. If for whatever reason it's not centered, let's say it locked onto the quadrant of the circle, you'll have to reselect that point. So got the points located at the center of the circles. I'll hit enter. You can now see the holes being created. They've got the countersinks and they go all the way through the part. From here, if I want to stay within this tool, I could select OK and create new operation. We're going to stay within the tool because we need to create these 0.188 diameter holes that are 0.25 deep. So I'll go to OK, create new operation. This time, I'm not going to use countersink. I'm going to use simple. The plane orientation stays the same. For the diameter, change this to 0.188 and set the depth to 0.25. And even though I put in 0.25, I need to set it to distance as opposed to through all. So distance 0.25. Once you fill out all this information, go up to add position. And this time I'll select the 6.188 diameter circles. From here, I'll select OK, or I'm sorry, from here I'll hit enter. And then you'll see those holes being created. These holes do not go all the way through the part. If they break through this back wall, we've got a problem. So what I would do, inspect it from both sides. I don't see anything breaking through, and then let's look at it from this direction. You can see there is a drill point angle at the bottom of the hole. So everything looks good. Fit my screen. I'll select OK. And then I'll save the work. Yes, sir.
I have a question. I accidentally left the through all on the second holes that we.
Okay, not a problem. Can I see your screen?
Yes.
All right, let me stop sharing real quick. All right, so exit out of there. And actually, no, you're still in the tool, right?
Yeah.
Set it to distance. And then I tumble to view. Did it update? Yeah.
Okay.
So yeah, you didn't exit the tool, so you can still make changes. for if you did exit the tool, it's still not a big deal. We can go back in and we can fix it easily enough. So let
Okay.
me show you how I go about doing it. Hit the green check real quick. And let's say for whatever reason you realize that the hold on. Oh, go back. Can I see your screen again?
Oh yeah, sorry.
No problem. So
Okay.
if you, for whatever reason, needed to change the depth of that hole, what you would do is go to the solid manager, go to view, and go to solids, and expand the solid. And then you see where it says simple at the very bottom, right click on that. And then go to edit parameters at the very bottom of that drop-down menu. Brings you back to this page.
Oh, I see.
And you can change it if you needed to.
Okay.
So you would make a change, you would hit the green check, and then you'd have to regenerate the entire model, and it would update.
How do you regenerate that?
Okay, so let's just make the change to it real quick. So make it go through all. So scroll down, make it go through all, and select the green check. And you see how it's got that, there's like a there's a question mark or something next to it. Now the two green arrows that are following each other, hover over it for a second. What's it say?
This one?
Yeah, regenerate selected, regenerate it. And that'll update your model. Now, if you look at like tumble your view, see how the holes go all the way through. Now here's something that makes people crazy. You see how those holes are highlighted?
Yes.
Reason being is you've got that feature on the solid selected. Select the solid itself at the very top, the uppermost or the top level. No, at the see inside the solid manager.
Inside here, yes.
Yeah, select that one.
This one here?
No, the solid is the top level, right there.
Okay.
And the solid, no, you see how it's not yellow anymore?
Okay.
So people have that selected and then they exit the solid manager and it's highlighted and they can't figure out how to turn it off. So what you need to do is go back to the simple hole, right click, edit parameters, scroll down, set it to distance, select OK. You'll need to regenerate. And then I would select the solid or the top level feature. And then you're good.
Voila.
You're good. So yeah, there is the ability to make some changes to the solid model once you create it. It's not as forgiving as some other softwares, but it still gives you some, some useful tools.
Okay, cool. Thank you.
You're welcome. All right, so let's do this. Let's take, I've been going for quite a bit. I'm a little burnt. Let's take 15 minutes. Actually, let's take 10 minutes. I'll start back up at 7:15 and we'll continue with this project. If everyone's cool with that, I'll just, we're almost done and we'll finish it up and then I'll take roll and we'll call it a night. I need to walk away for about 10 minutes and I'll start up at like 7:15. That cool with everyone?
Yeah.
All right,
Thank
cool.
you.
So let's take a break. I'll start back up at 7:15.
Cool.
Hey, Pat, the recording. Hey, Pat, you there?
Okay, so from here, we'll go back to the project page. And I'm looking at the next step. So use the hole tool to create the 1/4 holes. We did that. Use the hole tool to create the 0.188 diameter holes. We rearranged the order. So we've already done step 9. I'm going to relocate this or reposition it when we're done here. We're on to step 10. Use the extrude tool from the solid tab to create the 1.1024 diameter pocket on the inside face as shown. If I go to the drawing and I zoom into this section view, so section AA, there's a pocket. You can see it here, but this cross section shows us a little bit more. And this will be for a bearing. There's going to be a bearing pressed into this pocket. So the pocket measures 1.1024 in diameter, and the pocket will be 0.3125 deep from this edge to this edge. So I'll go back to Mastercam. And I'm going to change my construction plane back to the right side. So if I go to C plane, set it to right. From here, I'll draw in a circle centered on this hole. And the diameter value, I'll have to check the blueprint again, 1.1024. So 1.1024. I'll go to wireframe, circle center point for the diameter point, or for the diameter value 1.1024, and then I'll let my cursor lock onto the center of the existing hole. I'll check the diameter value. I'll select OK. I'll now use the circle to cut 0.3125 deep into this wall. I'll go to solids, extrude. The chaining dialog box becomes available. I'll select the circle that we just created. I'll select OK. And we're going to use cut body. I'm not seeing anything happening, so I'll need to change the direction. I'll select reverse all. And then for the distance, I'll type in 0.3125 and hit enter. From here, I'll select OK. And I'm tumbling the view and I'm inspecting the preview. Everything appears to be correct. So I'll look at it from an isometric view. Oh, I'm going back into that tool again. Right click, isometric. And if I go back to the drawing, I can compare the default isometric view to what I have on my screen. It appears as if I have all the holes on the inside of this part. I'll need to create the holes that I see on this top face right here. So let's do this. We'll go back to project page. Let's check the instructions. So, all right, step 12. Let's see here. So actually I got a duplicate here. So step 9 and step 11 are the same. So I'll update this after class or after when we're done here. For the next step, step 12, use the extrude tool from the solid tab to create the 1.4 diameter hole on the top face as shown. Go to the drawing.
Patrick, sorry to interrupt real quick, but how
No
deep was that extrusion for the bearing seat?
0.3125, 5/16.
0.3125. Okay, that's much better.
Okay, cool. Did it go all the way through?
Yeah.
Okay, yeah, that won't work. All right, so we're going to create one instance of this 1.4 diameter hole that goes through this top face. And we're going to use this dimension and we're going to center it, and then we're going to use this 1-inch dimension. So let's see here. So let's go back into Mastercam. Now watch how I place this hole. I'm going to go to wireframe, circle center point. For the diameter value, I'll set it to 1.4 and hit enter. I did not set my construction plane. So right now the circle is planar with the right side plane. If I come down here where it says C plane, left click and then set it at the top, you can see that the orientation of that circle has changed. The circle is now planar with the XY plane of the top plane, and it's also planar with this top surface right here, which is what I need it to be. I want to place this circle relative to this midpoint. If I look at the drawing, the hole is centered on the part and it's one inch from this edge right here. So this dimension is telling me it's 1 inch from this edge. So inside of Mastercam, what I can do, if I hold the shift key down and let my auto cursor lock onto the midpoint of this edge, left click, this control axis becomes available to me. If I hover over the x-axis control and type in -1 point, enter once, enter twice, and it's not functioning the way I thought it would, enter again, you see the circle is moved to that location, 1 inch from the identified point. I'll select OK. Let me do that again. We're going to draw in a circle that measures 1.4 in diameter. I want to place it relative to the midpoint of this edge. Hold the shift key down. Let your auto cursor lock onto the midpoint of that edge, left click. Position your cursor over the x-axis control. I'm not clicking on anything. I'm just positioning it over the x-axis control. It changes to the color yellow. I'll type in -1 point. I'll hit enter once. You'll see the whole triad move or the whole axis control move. I'll hit enter a second time. Then when I hit enter a third time, you see the circle being created. I'll select OK. I can now use a circle to make a cut through this top face. I'll go to the Solids tab. I'll use Extrude. I'll select the circle, and then I'll select OK. Now, because there are an even number of cylinders, I could set this to through all. Or what I'm going to do, if it was an odd number of cylinders, I wouldn't be able to use this method. So what I would do, I would set it to distance, and I would just increase the distance until the full diameter cuts through this this cylindrical surface right here. What you don't want to have, you don't want to have a small remnant. Let me go down a little bit. Yeah, you don't want to have this extra material here. So I'm just increasing it enough so that it completely cleans up. I want a complete diameter through this cylindrical face right here. So I've got it set to 0.6125. That's more than enough. I'm just inspecting it, making sure that the full diameter goes all the way through. From here, I'll select OK. And then I'll look at it from an isometric view. How's everyone doing?
I have a question.
Yes, sir.
My C plane is all out of whack.
Can I see it?
Yes.
So go to, see how it says C plane? Left click on that. It says 3D. So interesting. Look at it from, so close out of all those tools, close out of the circle center point tool right now. I think it's fine. You tumbled it. So hit isometric.
Yeah, so that's an isometric view right now.
Okay, so go to, so when you initially created it, did you start on the top plane?
I manually changed it and then to adjust it.
So what you want to do is you want to set it to the front plane.
Okay.
Maybe not.
Oh.
Okay, so I got it. So look at it from a, do me a favor, go to your plane manager. And select top. I just need to figure out where I'm at. Select top and hit equals. And then right click isometric.
Oh.
So
Okay.
you're where you need to be. So now let's do this. Create a circle, go to circle center point. And set the, yeah, so everything looks good. Set the diameter 1.4.
1.4.
Yep. And then hold the shift key down and let your cursor, auto cursor lock on to the midpoint of that edge right there. Doesn't seem to be locking on. There you go. Left click. Now position your cursor, hover your cursor over the red axis control. Don't click on it, just hover over it and it should highlight. Now type in -1 or -1, yeah.
-1.
-1, correct.
And then hit enter.
Yep, hit enter once, hit enter a second time.
Second time.
And then you'll probably have to hit it a third time and it should show you, it should place the circle. Yep, looks good. Hit the green check.
And
then just do an extruded cut so that it breaks through. I think I had like 0.6125 or something like that.
Okay, thank you.
You're welcome.
I have a question.
Yes, sir.
To figure out the diameter of that 1 inch 1025, did we subtract the 181 from?
No. So if you look at the blueprint, hold on. Can you see it on my screen? So
Yeah,
you see this dimension right here, this 0.3125 right here. It's from this edge. So this edge represents the bottom face of that circle, of that circular pocket. And this is the bottom edge of the bearing pocket.
So what's the 1 inch?
The 1 inch is coming from this right here. So this is the open face of the crankcase right here. My cursor's on it.
I'm talking about the one on the, I'm talking about the diameter hole that doesn't go through the part that's on the bottom face, not the top face.
Diameter hole.
This one right here.
I can't see it.
124,000. 102,410.
Okay, so that diameter is
Right there.
it's from here to here. So this one is showing us this diameter value
How do we know the depth of that?
by this dimension, this 0.3125 dimension right there.
Oh, okay.
Got it?
Yeah, I see it.
All right, cool. All right, so we'll go back to Mastercam. Now, if you go to the drawing, well, let me go back to the drawing. And you zoom into, or we look at this view, we're going to place this collar here. Once again, there's 0.201 diameter, they're 1/4 threaded holes. So all this information is, repeating itself all over the part. But this time there's 4 of them instead of 6. They're equally spaced. So this time they're 90 degrees apart from one another. And if you can see that they're not located on one of the quadrants. So we're going to rotate it 45 degrees. So let's do this. We'll go back to Mastercam. We're going to use wireframe, bolt circle. Let's start by identifying the base point. Lock onto the center of the existing circle. Don't lock onto the quadrant, lock onto the center. set the number of circles to 4. For the diameter, this is the diameter of the theoretical circle. That's going to be 1.8, given to us by this dimension right here. So the diameter is 1.8. For the arc diameter, set it to 0.201. And let's rotate the start point to 45. So start angle, set this to 45. And if I look at it from a top view, yeah, that's correct right there. So they are equally spaced, so 90 degrees between them. At angle 0, it's at the 3 o'clock. So I wanted it center between angle 0 and angle 90, or the 3 o'clock and the 12 o'clock. So I set it to 45 degrees. From here, I'll select OK. From here, I'm going to draw in, or I'm going to create the 201 diameter holes with the 0.265 countersink. Let's do this. Let's go to solids. We're going to use the hole tool. For the plane orientation, let's set it to top. For the type, I'll set it to countersink. And let's set the diameter 0.201. The countersink diameter is 0.265. And the countersink angle will be 90. And I don't want to use through all because it's going to shoot through the bottom of the part. So let's set it to a distance that will break through this wall. So let's try 1 inch and see what it does. We can always come back in and make changes to this value. So I'll set it to 1. And then underneath the positions field, I'll select add position. And then I'll select the 4 circles that we just created. I'll hit enter. And if I tumble my view, you can see that these holes go all the way through. I don't have any extra material on this edge right here, so this looks good. I'll select OK. I'll fit the screen. Now, I don't think I've saved my work in a while, so this would be a good time to save my work. How's everyone doing?
Good.
Doing good? All right. Let's do this. Let's go back to the drawing.
Patrick, I had a question real quick.
Yes, sir.
When we created those holes from the top, if we had an option to go through it all, I noticed that by accident I did it, and
It shoots through the bottom.
It shoots through the bottom, so
Yes.
it kind of did both all at the same time.
Yes, but there's no countersink on the back side of on the bottom face.
That's true. Yes.
So there's no countersink on this end, whereas you have the countersink on this side. So
Okay.
it kind of works, but it doesn't complete the job, if you know what I'm saying. So to avoid that, I just came up with a number that went all the way through, but did not come through the bottom wall right here. And like I was saying about this one, I could have made this one go all the way through too. But if it was a scenario where it was an odd number of cylinders, that wouldn't work, would it?
No.
So yeah, so we're gonna do it this way. We're gonna approach it from this, with this method. All right, so from here, I've got a 0.188 or a 0.1875 diameter hole. That's 1 inch from the existing 1.4 hole. I go back to the drawing. So this hole right here, it is 0.1875 in diameter or 0.188. It's a rounding issue, so we'll call it 0.188. And it's to a depth of 1.38. and it's in line with the existing hole, and it's 1 inch from center to center. I'll go back to Mastercam. We're going to draw in that 0.188 diameter circle. I'll go to wireframe. I'll go to circle center point. Now, if you typed in 0.188 or 0.1875, either one is acceptable. What you're seeing on the drawing is a rounding issue. So if you type in 0.1875, we're talking a half a thousandths difference, 0.0005. I want to place this hole relative to an existing hole. Once again, I'll hold the shift key down. I'll let my cursor lock on to the center of the existing circle, left click. I'll position my cursor over the control axis, -1. Enter once, enter twice. I hit enter a third time. You see that circle being created. I'll select OK. How's everyone doing?
Good.
Nice. Okay, so from here, go back to the solids tab, go to hole. This time we're going to use a simple hole. So go down to the hole style, set it to simple. Set the diameter value to 0.1875. And set the distance. If you go to the blueprint, the distance is 1.38. So set the distance 1.38, hit enter. And then I'll come back up to the positions field, and underneath the positions field, you'll see add position. Let your cursor lock onto this circle. You'll see a point appear. Hit enter. And then you'll see that hole being created. Now, this hole is designed to intersect this hole. So if I look at it from a shaded view or a transparent view, and you zoom in, this is what you should be seeing. You should see these two holes intersecting each other. And it looks good. So I'll select OK. And then I'll look at it from an isometric view. And this would be a good time to save my work. And I'll take it out of, or I'll turn off translucency. And now I'm looking at it in a shaded view. How's everyone doing up to this point?
Good.
Good? Okay.
Good.
Let's look at the instructions real quick. Okay, so we're on step 16. It says use the circular pattern tool from the solids tab to create 5 additional copies of the features from the top face as shown. So what we need to do, instead of repeating that whole process and creating, another hole, another pattern, another another group of the quarter 20 thread holes, and then another 0.188 diameter hole, we're going to use a circular pattern tool from the solids tab. Before we
So did I jump? Sorry to interrupt. Did I jump the gun with that question that I asked earlier?
What was the question again?
About like duplicating, like going straight through and then going through the other end and.
A little bit.
Okay.
So not a problem. Not a problem.
Sorry.
Not a problem. Not at all. So what we're going to do is we're going to use a circular pattern to create 5 additional instances of what you see on this top face. The trick with this tool is it likes to revolve or create this pattern around the z-axis. And right now my z-axis is perpendicular to this top face. I want the z-axis to run through the center of the part, or I want it to be collinear or coaxial with the center of this bore right here. To do that, let's set the construction plane to the right or to the left. So if I go to C-plane and I set it to right, you can now see that the Z-axis runs through the center line of the part. And that's what we need it to be, or that's where we need it to be for this next step. So C-plane is set to right. From the solids tab, I'll select circular pattern. And Mastercam is asking us to select one or more solid features or operations to be copied. You can select them from the graphics window or from the solids manager. Okay, so the trick here is we're going to select them from the graphics window. Select the face. Don't select the edges because you might be selecting wireframe geometry. I'm selecting this face. I'm selecting this face. Now, because they're a group, you see how they all became selected? And then I'm going to select this face. So I selected the faces of the holes. Be careful. Don't select the outer part, or don't select any of these faces. From here, I'll select OK. And you're getting this weird preview. Reason being is some of the settings aren't lined up yet. For starters, where it says distribution, set it to full circle, and that'll equally space it. And then increase the number of instances. I had to increase it to 5. So I selected full circle, and then I increased the number of instances to 5. I'm tumbling the view. Everything appears to be correct. I'll select OK. I'll look at it from an isometric view, and I'll save my work. Now, if I go back to the drawing and I'm looking at the isometric view that's provided with the drawing, I believe I have everything, but the one thing that I can see that's missing is this filleted or rounded edge on the back face of the part. And if I look at this section view, you can see that there is a fillet or a radius value of 0.125 all along the back edge of the part. So I'll go back in the Mastercam. This is the edge I'm talking about right here. I'll go to the Solids tab, and I'll use the Constant Fillet tool. The solid selection the solid selection dialog box appears. I'm using the default settings. If I select this edge and hit OK, let's see what happens. The radius value, you see how it applied that radius or applied that fillet to all connected edges. The only thing I'll need to do is I'll need to update the radius value, so 0.125. I'll select Enter. And it looks good. From here, I'll select OK. I'll look at it from an isometric view, and I'll save my work. And this will be a good stopping point for us tonight. Next class, we'll continue with this. We'll create the levels. We'll create the wireframe from solid, and then we'll create the material that we're going to machine this from. So for now, I'm just going to look at it from an isometric view, and I'll save my work.